Okay guys, so sorry I'm not there today, but we're going to take some notes. I did give this for homework on Friday. I'm not sure who did it or who didn't with the long weekend. If you did it, this should be just checking your work, and if you did not do it, then you need to follow along and just copy things down, and you might have to go back and kind of figure things out if it's going a little fast for you, because it was supposed to be homework. Okay, so basically what we're doing is we're talking about finding how many angles are in the interior of any polygon. So it starts off with a quadrilateral, and you notice here we've got a quadrilateral sketch that has 4 sides. And what they did is they went from one vertice and they connected it to any other vertices that were directly across from it. So in this case, we've got a quadrilateral, has 4 sides, and we formed 2 triangles. So 2 triangles were formed. And if there's 2 triangles, we know that there are 180 degrees in each triangle. So 2 times 180 is 360. And we know that a quadrilateral has 360 degrees. All right, the next one is going to be a pentagon. And I'm only going to abbreviate because my pen doesn't work. So you guys can assume that I have the agon part on there. So a pentagon, go ahead and draw a 5-sided shape. So 1, 2, 3, 4, 5. And then you're going to start at any vertex you want. And you're just going to connect to the other vertex. All right, so we've got 5 sides. We've got 1, 2, 3 triangles, and 3 times 180 is 540 degrees. All right, next one is a hexagon. Okay, so a hexagon has 6 sides, so 1, 2, 3, 4, 5, 6. Then you just connect 1, 2, 3. So that's got 6 sides, and we have 1, 2, 3, 4 triangles, and 4 times 180 is 720 degrees in that one. All right, next one is a heptagon. So that's 7 sides. They already have the figure drawn, so we're just going to connect the vertices. 1, 2, 3, 4. So there's 7 sides, and there's 1, 2, 3, 4, 5 triangles. So 5 times 180 is 900 degrees. All right, next one is an octagon. Octagon, and you guys can draw an octagon. Mine's going to look really bad, but try it anyways. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that doesn't work because that's concave. So let's try 1, 2, 3, 4, 5, 6, 7, 8. All right, that's really bad. 1, 2, 3, 4, 5. Okay, sorry, mine's going to look really bad. So you should have an octagon that has 8 sides, and it should have 6 triangles, and 6 times 180 is 1080 degrees. So if you notice the pattern here, you're taking the number of sides and you're subtracting 2. Subtracting 2. Subtracting 2. Subtracting 2. Right? So we're subtracting 2 and then multiplying everything, our answer is by 180. Okay? So that means that to find the number of triangles, it is n, so that's the number of sides, minus 2. And our formula is n minus 2 times 180. So this right here is the formula that we're going to use for these next items. All right, so here it is telling you to find the sum of those. So if you want to pause the video for a second and let them figure it out and then come back and check, but I'll go ahead and do them. So we're going to use that formula, which is n minus 2 times 180. So the first one is 15 minus 2 times 180. 15 minus 2 is 13, and 13 times 180 is 2,340 degrees. All right, number 2 is a 20gon. I guess there's not a name for that. So 20 minus 2 times 180. It would be difficult to draw a 20-sided figure without making it look like a circle. So 20 minus 2 is 18. 18 times 180 is 3,240 degrees. Number 3 is a decagon, which is 10. 10 minus 2 multiplied by 180, and that equals 1,440 degrees. And then the last one, a dodecagon, is 12. So 12 minus 2 times 180. That's 10 times 180, which is 1,800 degrees. All right, so this is just the basics of finding the measure of the interior angles of the polygon. Remember, interior means on the inside of the polygon. All right, next we're going to talk about exterior. Okay, this next part is talking about the exterior angles of a polygon. Now, if you have a polygon, so in this case, in this first one, we've got this triangle. The triangle is the polygon, okay? And then the interior angles is this angle, and this angle. Okay, so it's got 3 interior angles. Now the exterior angles are when you take these lines and extend them out. See how it extends it out? It looks kind of like a star. Okay, so those that are extended out, they make exterior angles. So measure 3 is an exterior angle, measure 2 is an exterior angle, and measure 1 is an exterior angle. And if you notice, all it's doing is creating a supplement with the interior angles. Okay, now in this activity, it's asking you to use a protractor to measure the angles, but what we're going to do is we're just going to make up angles based on their sizes. Okay, so let's say that this angle right here, that's supplementary to 2, let's say that that's 90 degrees. Okay, and then this one is an acute angle, so let's say that it's 40. Now it's a triangle, so it still has to have under 180. So if this one's 90 and that one is 40, then that means this one has to be 50. Okay, so go ahead and write those measures down. And if you did it with a protractor and yours are different, that's fine. We should still get the same thing. So if you look at measure of angle 1, if the measure of angle 1 is next to 50, those are supplementary because they make a straight line. So that means that the measure of angle 1 has to be 130 because they're supplementary. All right, the measure of angle 2 has to be 90 because those are supplementary. And the measure of angle 3 has to be 140 because they are supplementary. Now if you add all of those up, you should get 360 degrees. Okay, so just think about the fact that the exterior angles are the supplement of the interior angles. Okay, so let's do another one. Okay, so this one's a quadrilateral. We know that we have to have 360, so I'm just going to make up some angle measures, and I'm going to do it based on the fact that, you know, whether or not it's acute or obtuse. So let's just make it easy. This one right here by number 7, let's just say that that is 100 degrees. Let's say that this one is 110 degrees, and let's say that this one is 60 degrees, so that is 270, and I cannot do math in my head today, so 270 minus 360. So this one, okay, let's go ahead and change this to, let's change this to 80. Okay, that one means that this one has to be 70. Okay, so now we look. Angle 4, if the supplement to angle 4 is 70, that means that angle 4 has to be 110. Angle 5, if its supplement is 110, then that means that angle 5 has to be 70. Angle 6, if 80 is its supplement, then angle 6 has to be 100. And angle 7, if its supplement is 100, then it has to be equal to 80. So if we add all of those together, 110 plus 70 plus 100 plus 80, we get 360 degrees. Okay, so this was a triangle, and we did the same thing, 180 on the inside, but the exterior was 360. On this quadrilateral, we did the interior of 360, but the exterior angles were also 360. All right, so here we go. This is a, let's see, 1, 2, 3, 4. So this is a pentagon. So first of all, let's decide what a pentagon has to have angle-wise. So it has to have, I'm just going to write it right here, it has to have 540. Okay, so I'm just going to make up some angle degree measures. So let's say that this one is, right here, is 110. Let's say that this one is, let's just make it easy, is 110 also. Let's say that this outside angle is 110. So let's just say that they're all 110, which would work. 110 and 110. Okay, now if I do 1, 2, 3, 4, 5, so 110 times 5, oh, that's not going to work. Why don't you guys tell me that? So this one has to be, let's make this one 100, because remember they have to add up to 540. So 1, 2, 3, 4, 110 times 4 plus 1. All right, so that works. Okay, so now measure of angle 8, and actually I'm saying that this one is 110. Sorry guys, bear with me. Okay, so if this measures 110, then 8 has to be 70. If the measure of this one right here by 90, by measure of angle 9 is 110, that one also has to be 70. These are degrees. And angle 10, if that supplement is 110, it has to be 70. And measure of angle 11 supplement is 110, that one also has to be 70. And if the measure of angle 12's supplement is 100, that means that one has to be 80. So if we add 70 plus 70 plus 70 plus 70 plus 80, we get 360 degrees. So basically what that means is that for any size polygon, it doesn't matter what it is, a triangle, a quadrilateral, a pentagon, the sum of the exterior angles are always going to be 360. And really the thing to remember is that the interior are the ones, the interior are the ones on the inside. So these are your interior, inside of the polygon, okay? And the exterior are the ones that are created with the interior angles, okay? So just need to remember that. So the first formula for angles of a polygon are n minus 2 multiplied by 180, okay? So that's angles of a polygon. Okay, and exterior angles, this is interior. So exterior is always 360. It doesn't matter what kind of a polygon it is, even if it was the 20-agon. Okay? All right, now those answers for number 5 through 10. So 5 is an undecagon. Number 6 is an octagon. Sorry, octagon. Number 7 is a dodecagon. Number 8 is a heptagon. Number 9 is a non-agon. And number 10 is a pentagon. My stylus is not working today. Okay. Alrighty then. Okay, so I'm going to go through the answer choices on the next page, and then the work I want you guys to just go ahead and work on in class. I will complete the video, so after you're done with this next page, they can go ahead and stop the video, and you guys can work on it for homework and in the rest of class, and it is posted on Edmodo, that's where you're watching it at, so that you can go home and check your work. Alright, here we go. All right, so the first one, an angle which forms a linear pair with an interior angle of a polygon is called I'm going to write it out here on the side, exterior angle, right? So it's this whole linear pair part is the important part. So it's an exterior angle. All right, number 2, a polygon which is both equilateral and equiangular is a regular. That means all sides and all angles are equivalent. All right, number 3, a segment that joins two non-consecutive vertices of a polygon is called a diagonal. Okay. Number 4, the measure of an interior angle of a triangle is equal to the sum of the measures of its remote interior angles. Remember, that was when, and I'm going to draw it down here on the bottom, that was when if you had a triangle and then this line came over here and you had x over here, x is equal to 1 plus 2. So x is the exterior angle of the triangle, and then x remote interior angles are 1 and 2. So that's what number 4 is talking about. All right, number 5. Each angle of an equiangular triangle has a measure of 60 degrees. You guys know that. Number 6. An interior angle of a polygon and its adjacent exterior angle are always supplementary. Sorry, I'm going to abbreviate. Okay? And number 7 is an exterior angle of a polygon is always, sometimes, or never smaller than its adjacent interior angles. That would be sometimes. Okay? Because if you look back at what we did, it could have been acute or obtuse. So it just depends on the way that the shape looks. Okay? So what I want you to do is go ahead and start work on these. So numbers 8 through 12, and what are the rest of them? 13 and 14, and the rest of the worksheet. So all through 20, I think it goes to 21. Okay, go ahead and complete those in class, and then you can go ahead and pause the video or stop the video now, and you can watch it tonight to check your homework, and then tomorrow we're going to move on to something else. Okay, guys, hope you have a good day. Behave yourselves. Boys, no launching pencils on the pencil tray, please, or on the chalk tray, and I will see you guys tomorrow. All right. All right, guys, here are the answers for numbers 8 through 12. I think these are pretty straightforward. Okay, and here's the answers to number 13 and 14. All right, number 15. Okay, to find x, I took 180 because that's the measures of the triangle, subtracted 46 because that gave me this measure and this measure, and then I divide it by 2 because it's an isosceles triangle. So that gave me x. Now once I knew that x was 67, x and w are supplementary, so I subtracted 67 from 180 and got 83, which I think is wrong. Yes, sorry, this should be 113 degrees. Sorry about that. Okay, the answer to number 17 is 60 degrees. And I'm just going to be scrolling through these with the answers. Sorry, I'm going to run out of time on my battery, so I don't have time to show you the work, but I will show you the answers. 18n is equal to 112. Right, you would basically add all them together and subtract and solve for n based on the number of angles in that shape. All right, number 19. Z is 121, Y is 59, X is 49, and W is 72. So on this one, you just got to kind of figure out, that it's equal to 180. Try to, actually, I'm sorry, if you look at your Z's, remember, these are your exterior angles, so Z, Z, and Z. Remember, if you add those all together, they should be equal to 360 because all exterior angles of a polygon are equal to 360. So if you add those all together and solve for Z, then you can plug it back in and solve for the supplement to those angles, and that's how you get Y, X, and W. All right, and then for 20, you know that H, the measure of angle H, and then H minus 28 has to be equal to 180. So you solve for those. And then once you know what h is, you know that h right here is equal to the sum of this angle and that angle. So if you plug those in, you should get that answer of h is 104 and y is 35. And on the last one, x is equal to 50.